So we are trying to state whether each number is rational or irrational. So before we do this, let's talk about what each word means. I find it easiest to deal with decimals as opposed to fractions. So I'm going to give you the definition in my own words that I use in regards to decimals. If it is irrational, let's change that color. If it is irrational, that is going to be a decimal that never ends. So it's called a non-terminating decimal. Non-terminating is just a fancy math word to say that it never ends. And oops, what is that? I put an E? Oh, that was funny. That never ends. And usually this is represented as a dot, dot, dot. Or if you type it in your calculator, it'll just have a ton of numbers. And so then you'll know that it never ends. And the other thing is it has to be a decimal that never repeats. And when we say repeats, we're looking for a pattern, like 1, 2, 3, 1, 2, 3, 1, 2, 3, or 7, 8, 7, 8, 7, 8, or just 3, 3, 3, 3, 3. So if it's a decimal that never ends and never repeats, it is irrational. If it is not irrational, then it has to be rational. So there's lots of definitions for rational, like you can write it as a fraction, blah, blah, blah. All you really need to know is that if it's not irrational, it has to be rational. So let's look at this. The first one says negative 19. Well, negative 19 ends. It doesn't go on forever. So we know that this one is rational. The square root of 196. I like to think of my definition in terms of decimals. So I'm not going to just leave it like that. I'm going to go to my calculator and I'm going to type in the square root of 196 and see what it is. So let me pull up Desmos and type in the square root of 196. That's 14. That number ends. So that is a rational number. Now let's look at this decimal, 4.9878986 ... Well, we know it never ends because it has the ... So then we just have to see if it repeats. And there's lots of 9s, 8s, and 7s, but if you look for the actual pattern, 987, 89, 87, it does not repeat. For it to repeat, it would need to say something like 987, 987, 987. It would have to be the same pattern. This one is not. So because it's a decimal that doesn't end and it doesn't repeat, it is irrational. Now here we have the cube root of 216. Again, I like to deal with just decimals, so I'm going to go to my calculator and I'm going to change that to a decimal. So let me get rid of this. Now cube root is not one of your quick options over here. That's the square root. That's not the same. So we have to go to functions, go over here to miscellaneous, and this is where we're going to get the cube root. So up top here, we want it to be the cube root, so we're going to hit 3. And then inside, it was 216. So we're going to type in the cube root of 216. That equals 6. So that is a rational number. And then we have 1.01010101 ... We know it never ends, but it does repeat, right? We have 0, 1, 0, 1, 0, 1. Since it repeats, it is rational. In order for it to be irrational, it has to never end and never repeat. Now, I do want to mention one more thing about roots. It is very common that you will have a root that is irrational. Anything that's not a perfect square. So when I mean 49 is a perfect square because it has a perfect answer, 7. But if you tried the square root of 48, let's type that in our calculator. Square root of 48 is this, 6.928, blah, 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 blah. It never ends, it never repeats. This one is irrational. So some roots are rational, and some roots are, I don't even remember what this decimal was, 9, 2, blah, 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 blah. Some roots are irrational. So for me, I don't automatically look and see a root symbol and assume it's one or the other. I always turn it into a decimal. If it's a decimal that never ends or never repeats, it's irrational. And if it does end or it does repeat, then it's rational. Another way to think of it is either has to be rational or irrational. So if you know it's one, it can't be the other. And if you know it's another, it can't be that. So anyways, I hope this helps.